Welcome back to Cosmic Earth. Today we are exploring a massive discovery in space. Scientists just heard something incredible. It is the steady hum of the entire universe. This is not actual sound traveling through air. Space is a vacuum after all. Instead, these are giant ripples in the fabric of space-time. They stretch and squeeze everything in their path. This discovery was announced on June 28, 2023. A global team of astronomers shared the news. They had been working on this for 15 years. Their patience finally paid off in a big way. Think of the universe as a giant, crowded dance floor. Massive objects move around and create waves. The main source is pairs of supermassive black holes. These monsters are millions of times heavier than our sun. When two galaxies collide, their central black holes meet. They begin to orbit each other in a slow, deadly spiral. As they spin, they churn up spacetime itself. This sends gravitational waves rippling across the cosmos. These cosmic waves are absolutely mind-bogglingly huge. A single wave can take years to pass by Earth. Their wavelengths are measured in light years. This is why they were so hard to detect. You might remember the LIGO experiment from 2015. That observatory detected short, quick bursts of gravitational waves. Those came from small black holes colliding, but LIGO is too small to find this deep background hum. To catch these long, slow waves, we needed a larger detector. In fact, we needed a detector the size of our galaxy. Since we cannot build that, we had to find one. Fortunately, nature already provided the perfect tools. These tools are called pulsars. They are the dead spinning remnants of massive stars. Pulsars spin incredibly fast and shoot out beams of radiation. They act like highly precise cosmic lighthouses. The pulses of light from these stars are extremely steady. They are so regular they rival human atomic clocks. Scientists can predict their arrival down to the nanosecond. This makes them perfect for measuring tiny changes in space. Astronomers created something called a pulsar timing array. They selected dozens of pulsars scattered across the Milky Way. By monitoring these stars, they created a giant net. Any passing wave would disturb this net. When a gravitational wave passes through the galaxy, it stretches space. This alters the distance between Earth and the pulsar. The pulses will arrive slightly earlier or later than expected. It is a tiny shift, but highly measurable. Seeing a shift in one pulsar is not enough. That could just be random cosmic noise. To prove it was a gravitational wave, they needed a pattern. They had to see correlated shifts across many different pulsars. This specific pattern is called the Helling-Downs curve. It predicts how pulsars should shift based on their position. If two pulsars are close, they shift similarly. If they are at 90 degrees, they shift differently. The North American Nanohertz Observatory led this work. They are known as Nanograph for short. They use massive radio telescopes like Arecibo and Green Bank. They spent 15 years gathering data from 67 pulsars. They were not working alone in this quest. Teams in Europe, India, Australia, and China did the same. They all looked at the same cosmic clock network. When they compared notes, the results matched perfectly. Finding this signal was incredibly difficult. The shift in arrival times is tiny. We are talking about fractions of a microsecond over decades. It required extremely advanced statistical models to pull out. If we could convert these waves to sound, it would be low. It would sound like a deep, rumbling bass. It is a constant background noise of the cosmos. Astronomers call it the gravitational wave background. This background is made of hundreds of thousands of binary systems. These are supermassive black holes slowly spiraling together. They are located in the centers of distant galaxies. Their combined signals create the continuous hum. Hearing this hum helps us understand galaxy evolution. Galaxies have been merging for billions of years. When they merge, their black holes must merge too. This hum confirms that this process is very common. This discovery might solve the famous physics mystery. It is known as the final parsec problem. Theories suggested that binary black holes would stall when close. They should never actually merge, but the strength of this hum suggests otherwise. The black holes seem to get past this barrier. They continue to spiral inward and emit waves. This means they do eventually merge into single giants. There could be other sources for this hum. Some waves might come from the early universe. They could be leftovers from the Big Bang itself, or they could be caused by cosmic strings. Cosmic strings are hypothetical cracks in spacetime. They are incredibly thin but massive structures. They would have formed right after the Big Bang. If they exist, they would vibrate and emit waves. This discovery opens a brand new window. For centuries, we only looked at space with light. Now we can listen to it using gravity. This is like going from silent films to talkies. Astronomers are not stopping here. They want to map the entire background hum. They want to identify individual black hole pairs. This will let us pinpoint exact merging galaxies. Future space missions will help this search. The LISA mission is planned for the late 2030s. It will be a giant gravitational wave detector in space. It will work alongside pulsar timing arrays. This discovery is another win for Albert Einstein. His theory of general relativity predicted this in 1916. It took us over a century to fully prove it. His understanding of gravity continues to hold up. Space is not a silent, empty void. It is a dynamic, vibrating cosmic symphony. We are just beginning to hear the first notes. There is so much more waiting to be discovered. Thank you for watching this video on Cosmic Earth. If you enjoyed this discovery, make sure to hit like. Please share and subscribe to our channel for more space. Tell us what topic we should cover next in the comments.